your packet. When it comes to the test on Monday, or quiz, or whatever we want to call it, next Monday, you will need to know the volume formulas. I will give you the lateral area formulas. Okay, so you do not need to memorize the lateral area. You do need to memorize the volume formulas for the quiz on next week, Monday. Volume is how much space there is to fill the particular object. So if we think of filling it with water or sand or whatever, that's how much space it takes to fill it. Lateral area is the area around the sides of it, not the top and bottom, but just around the sides of the figure. Okay, so around the sides of the cube, or in a rectangular box, around like the sides of the Kleenex box, but not the top and the bottom. Okay. Total area, which you will be asked for in our examples and in the homework, is when we take that lateral area, all of the sides. Lateral means sides. So lateral area is the side area. Total area takes that lateral area and adds to it the top and the bottom. Okay? So you will need to know that. But you do not need to know your lateral area formulas. Those will be provided. Today we're going to look at the 12.1 portion of the notes. So we're not going to do all 8 of the examples, but we'll do the examples that apply to lesson 12.1. The first question asks us to find 3 things: lateral area, total area, and volume of a rectangular prism or with a length of 6, width of 4, and height of 2. Since we're asked to find 3 different things on this question, small would be beneficial. Lateral area is a formula that you do not need to memorize. That's one that will be on the quiz for you, but we can look up. It says 2 times length height plus width height. What that formula is doing is finding the area of the front of the box. That would be the length height, would be area of the front. And the area of the right side, which would be the width times the height. And then we're doubling it because there's a front and a back, and a left and a right. So that's why there's that 2 there. So that's what the formula is doing, but you don't need to memorize the formula. So we can just plug our numbers in here. We've got 2. The length is 6. The height is 2. The width is 4. The height is 2. Order of operations says that we need to work within the parentheses first, and in those parentheses multiply first. So that's 12, 8, which is 20 times 2 gives so a lateral area of 40. That's the area around the sides of the figure. Total area, the formula is not provided on the sheet. For any shape, total area is lateral area plus area of the bases. Okay? Total area says let's take all of the sides and add to it the top and the bottom, the bases. So you need to know that for the test. It's just kind of a general idea of what total area means. It's not so much a formula. So for this problem, total area is that lateral area of 40 plus the top and the bottom. Well, the top and the bottom are the same size, so we can say 2 times. And how would we find the area of the bottom of this? 6 times 4. The length times the width. So we still need to know those area formulas from the last chapter, that the area of a rectangle is the length times the width. So the bottom of that box would have an area of 6 times 4, as would the top. So that's why we're doing 2 times, because there's a top and a bottom to add in here. So 2 times 6 times 4 is 48, plus 40 is 88. And then we are asked to find volume as well. The volume formula is length times width times height. That is a formula that needs to be memorized. The volume formulas need to be memorized. So that is 6 times 4 times 2, which is 48. Now, there were no units on this question, so we don't need to put them in our answers. But let's say there were units. If our length and width and height were measured in centimeters, what unit would volume have? Centimeters cubed, because it's multiplying 6 centimeters times 4 centimeters times 2 centimeters. Of them gives us centimeters cubed. What about the lateral area and total area? What kind of units would they have? Squared, because they're areas. So just like in the last chapter, area was squared units, in this chapter, area is still squared units. So if there are units in the question, make sure you include them in the answer. Area squared units, volume has cubed units. Questions? In question 2, we're asked to find lateral and total and length of a rectangular prism again. So again, we have a shoebox. But this time we know our width is 8, and our height is 5, and volume is 360. So we don't know the length, so that'll be the first thing we find. If volume is 360, what's our volume formula? Length times width. Well, we know the width is 8 and the height is 5. We don't know the length, but that's what we're solving for. How do we solve for it?
Use the 5 a 10 times.
Find the lateral area. Lateral area, we'll use the same formula as we did in the first question, which is a formula that does not need to be memorized. It's finding the area of the front and the back and the left and the right. So that's 2 times, we know our length now is 9, and height is 5, and our width is 8, and height is 5. So inside that gives us 45 plus 40, 85 times 2 is 170. Calculator use is acceptable and encouraged. I'd rather have you use a calculator and get it right than try to do it in your head and get it wrong. Total area, we said in the last question, is the lateral, so 170, plus the top and bottom, or the bases. So there's 2 of those, and how would I find the area of the top and bottom in this question? Yep, 9 times 8 would give us the bottom. The length times the width. 2 times that to cover both the top and the bottom. So 170. Why do we have the 2 in front of it? Because of the top and the bottom. So 9 times 8 would give us the area of the bottom, and the top would be the same. So we're doubling it to cover both of them. So that adds up to 314. For today's problems, when we think about our total area, we're always going to do lateral plus 2 times whatever the area of the base would be, because in our problems today, all of our figures are going to have a top and a bottom that's exactly the same. Questions on number 2?
which order you put the lateral?
It does not. You could do 2 times 9 or.
Wait, no.
Oh, for the lateral?
No, I'm saying like, do you have to do it like by length? Like, do you have to do it in order, or can you just like?
You have to make sure you're using the right pieces. So you have to make sure that in each pair you're using a height, that you're not doing the length times the width, because that would be the bottom, and we don't want the bottom and the top in the lateral area. And then just make sure that you're following the order of operations when you do your evaluation. So you're multiplying before you add.
Yeah, I'm saying like, do you have to do a specific order for like to do the problem? Do you have to start out with lateral area, total area, and then length, or can you just like find length?
Well, we needed length to find the lateral area because we used that 9 within the lateral area. So length had to be the first thing that we found because we needed it for lateral, and then we need lateral. So they kind of have to go in that order to find those 3 things. Question 3 asks us to find 2 things. Total and volume. It didn't ask for lateral. Of a cube. A cube is a special kind of rectangular prism, so a special kind of shoebox that has all sides the same. So the total area formula says 6 times side squared. Now, you don't have to memorize that, but let's think about why that formula is what it is. Squared. What would that be? Find the area of one side, because in a cube, all of the sides are what shape? A square. So by multiplying length times width, which happens to be the same, so we could just say squared, that finds the area of one of those sides. Well, how many sides does a cube have? So 6x squared is the formula for total area, because side squared will give us the area of one of those sides, and in a cube there are 6. There's a front and a back, a left and a right, a top and a bottom, and they're all the same. So 6s squared is the formula for total area. 4. 4 squared will give us our total. Make sure you follow your order of operations. Do not multiply first and make it 24 squared. Order of operations says that we need to do exponent or multiplying. So this is 6 times 16, which is 96. Then we're asked to find volume. Volume formulas do need to be memorized. A cube is really just a special case of our first questions. So in our first questions, the volume was length times width times height. Well, if they all happen to be the same, how could we simplify that? Side cubed. That's actually why we call a power of 3 cubed, is because it gives the volume of a cube. Okay, so there's a reason why we call a second power squared. It gives the area of a square. A third power cubed. It gives the volume of a cubed. And beyond that, we don't really have a special name because we don't work in 4 dimensions. We don't see 4 dimensions. So a 4th power doesn't have a physical meaning for us. So we don't have a special name for it. But square and cube have physical meanings in geometry for area and volume. So 4 cubed, or 4 to the 3rd power, is 64. The next question asks us to find side length and total area given a volume of 64. 3, because in number 3, the volume area would be 96. Repeating the exact same problem we just did, we're going to change this to 16. So if volume is equal to 216 and volume cubed is volume is side cubed, we need to think of what number do I multiply by itself 3 times to get 216. You probably don't know that off the top of your head. So what we do is we grab our calculator and do 4 times 4 times 4. Nope, that's 64. 5 times 5 times 5. Nope, that's 125. 6 times 6 times 6. Oh, that's 216. So we just do some guess and check to figure out what number do we multiply by itself 3 times to get the number in the question. All your perfect cubes. So you just do some guess and check on your calculator. Total area then, our formula is 6 times side squared. So 6 times 36 gives me what? What's 6 times 36?
216.
216. This is a special case of the volume and the area being the same. They are not always the same, but in this special case they are. The next problem will be our last one for today. We are asked to find lateral area, total area, and volume of a prism with a base of an isosceles triangle. So what I'm going to do is draw an isosceles triangle. And that triangle, and then it says height of 10. That's not the height of the triangle, but we have a 3-dimensional thing here. So we're going to extend that triangle out to make kind of like a tent. And that is our height of 10. That height of 10 is the distance between the top triangle and the bottom triangle. If we look on our formula sheet, we do not have a formula or a drawing that looks like a triangle prism. But down towards the bottom, second to last one, it says just prism in general, and there's no picture for it. And it says that the lateral area of a prism is per, P-E-R, of base times height. What do you think per of base means? Perimeter of the base times the height of the prism. How do I find the perimeter of that base? Add up all the sides. So what do we get? Add up just the sides of the base. So just the sides of the triangle. 18. Okay. So we add up the sides of that triangle, just going around the edges of the triangle. 5 plus 5 is 18. And then the height of the prism is 10. So that gives us 180. So perimeter of the base times the height for lateral area. Total area, we said at the beginning, was always going to be lateral plus, today we're working with 2 bases because there's a triangle on each end of this thing, times their area, the area of those triangles. So, in the last chapter, we learned about finding area of triangles. What is the formula for area of a triangle? You can't forget those area formulas from the last. Of the triangle. 8. And the height of the triangle. We don't know it. We know the height between the triangles, but the height in the triangle would be straight from the top of the triangle to the bottom, and we don't know it. How do we find it? Pythagorean theorem. Split that 8 into a 4 and a 4, and that's going to give us a height of 3. 3, 4, 5 is that special triangle that if you learn to recognize it, saves you time from having to do a squared plus b squared equals c squared every single time. So our height of our triangle is 3. Okay. So don't forget your area formulas from the last chapter. You need the area of a triangle formula here. When we calculate this all out, adds up to 204. Lastly, for this question, it asks for volume. If we look on the formula sheet, it says that it is the area of the base times the height of the prism. So once again, how do I find the area of that base?
1/2 base times height.
1/2 base times height. And then times the height of the prism. So 1/2 base of 8, height of triangle is 3, height of prism is 10. So that gives us 120. Questions? So tonight, just the 12.1 portion of the assignment. Tomorrow we'll work with 12.2.